Hello, hello, fifth graders. It's your teacher, Mrs. SJ. Classic, a little late. Thank you so much for being here, for waiting, and for being ready. Today's lesson is all about adding and subtracting fractions. More specifically, let's take a look at our teaching point below, which tells us exactly what we need to be able to do by the end of the lesson, which is I can add, and go ahead and say this out loud with me, I can add and subtract fractions and mix numbers with unlike denominators. We know the key part of this, add and subtract. You know how to add and subtract numbers. This is something you've been working on since arguably as soon as you came out of the womb, right? Uh, how to bring things together. This is a skill that you start in, seeing in the world, but start learning conceptually when you're in TK, when you're in kindergarten, and first grade, and second grade, and now you're in fifth grade. And we're not just adding and subtracting whole numbers, we're adding and subtracting fractions. And we know that fractions are part of a whole. And really, that our fractions can be mixed numbers, right? A mixed number means it is a whole number mixed with a fraction. You know that the denominator tells us how many times that whole piece has been cut in half, how many times it's been split up. So of course, we're going to come into contact with denominators that are different from one another. Even within our elementary school, the fraction of our classroom is, well, now it is about 29, but this is different than a whole class in Mr. Miller's room. Mr. Miller's got 24 students, so his whole class there's only 24 kids versus our class is 29. Those denominators are different, right? So now that we've kind of reviewed what we've been talking about over the last couple of weeks, we're going to get ready to dive in. Yesterday we spoke about we spoke, well, not, we didn't just speak about it, we discussed how fractions can show up in our daily life. And I loved it. What better a way to consider how fractions show up than how they show up with our food? Cake, especially. I made a mistake. It should have been tres leches cake. Shout out to Miss Rubin, who let me know that you can't have 3 milk. You have to have 3 milks, right? Tres leches. S is like plural, so I just wanted to put that out there and correct myself. Today, we are going to take something similar and different. It's similar in the fact that it is real life. It is different in the fact that we aren't talking about cakes today. We are going to be talking about cats. Kind of on like a sea kick. I'm not sure what's up. But yeah, we're going to talk about cats. And you're like, you might be thinking, well, Mrs. SJ, what do cats have to do with fractions? What a great question. What? Well, first of all, how many of us watching here has a cat? Or maybe has a family member that has a cat? I'm going to wait and see if we can get any people to chime in and maybe even let us know, like, what's your hypothesis? How might we use fractions if we have cats? Now, of course, this could be any other animal too, right? But today we're going to talk about cats. So for those of us who have cats or have a friend who has a cat or have family that has a cat, chime in the chat and let me know, how might we be using fractions when it comes to cats? So I'm going to give a little think time. And as I'm doing this, I want to pull up a few things. I'm going to wait a bit because I see there are 12 of you here getting ready. Okay, I'm going to give a little bit more think time for this while I get myself set up. Okay, starting to get some people are chiming in. Oh my goodness. One friend of Ava has 5 cats, 5 kitty cats. Oh my gosh. Anybody else have someone with a cat or more than one cat? Because I definitely know Marco has at least 2 cats, 2 kittens. I'm gonna wait for a few more people to chime in. Remember that live chat is working. Give a bit more think time. And you might also consider writing down your predictions of why we're talking about cats with fractions. How could fractions help us if we have cats? How might fractions help us if we have cats? So with this, I want to give a little bit more think time, and then I'm going to pull up this document for us to start using. And bear with me because I really want to use this this window capture to do this. Let's try this one instead. Okay. I love it. I'm seeing more people are writing in. There it is. Okay. So this is going to show up right in front of us right now, and we're going to bring this over to the side so that we can take a look at this equation. So here we have our equation that our word problem story that we're going to use to start this off. Now, I have a feeling, I have a sneaking suspicion it's too small. So what I'll do is I'll kind of zoom in on these parts so that we can take a look at them. Okay, so read along with me. And I know that my face is kind of blocked off, but let's just make it work. So Cindy has 3 cats, all right? Tommy, Sammy, and Goldie, all right? Now, these 3 cats are real sweet, obviously. We love our kitties. Look at them. They're super cute. Now, this first part that we're going to talk about that I want to get us set up with is this is a very real thing. If you have a cat, you know that cats eat. You know that when a cat runs out of food, you got to buy more food, and many of us don't want to just buy small amounts of food at the same time. We want to buy enough so that we don't have to keep going back and forth unnecessarily to the store, right? Now, I'm not sure if that was what they had in mind when they made this story problem, but we're going to try this out. So take a moment to write this down on your page. And I'm also going to take some notes, and we're going to get ready. The first thing I want to note is each of the cats are eating a certain amount. So let's read through this. Cindy feeds them cat crunchies. Each day, Tommy eats 3/8 of the box. Sammy eats 2/5 of the box. And Goldie eats 1/4 of the box. Thank you so much, Dermot, for letting me know. Just use your flexibility tool if you can't find it, or you can pause this and then come back to it, okay? So I want to write this down, and I'm going to use a similar method that I used from yesterday, where we're going to have to consider different things happening. Now, I know that you can't see what I'm writing down. In a moment, I'm going to change the screen so that we can do some work and put this off to the side. So let's do this together. We have Tommy. I'm going to give myself space in between each of these because I really want to make sure my math is clear and that I'm not getting confused. We've got Tommy, we've got Sammy, and we have Goldie. Sweet Goldie. Okay. Now, I'm gonna, just for visual sake, I really like the fact that I'm gonna just draw a big box, and this is our crunchies box. Now remember, they don't each get their own box. They're not like that spoiled of cats. They all get different amounts that they're gonna eat, and we know cats. Cats are temperamental. They also know how to feed themselves regularly. They're not like my dogs. If I put out a lot of food for my dogs, they would have eaten it all. It doesn't matter if they were hungry or not. They will eat anything that you put in front of them. So let's take a look. Well, we know that Tommy eats 3/8 of the box. And let's see if I can actually do this. Perfect. Tommy eats 3/8 of the box, right? We have Sammy eats 2/5 of the box, and Goldie eats 1/4 of the box. Now, the first thing I want us to know is, now that we have that information, what is this question asking us? Well, let's look below. How much do the cats eat in all each day? I'm going to read that one more time. Cindy feeds them cat crunchies each day. So this is how much the cats eat per day. So I'm going to make a note. That they eat that every day. So what we're looking for is, how much do the cats eat in all each day? And we need to explain using numbers, diagrams, or words. Now check it out. I got numbers, I've got a diagram, I have words. I love using all of these strategies. They really help me so that I understand. You might be doing this in just using your numbers. You might choose to solve using diagrams. And also, words really help us out as well. So if we're trying to figure out how much they eat all in the day, well, we know we're going to need to add these up. But the first thing that should be going off in that beautiful mathematical brain of yours is that we have 3 different denominators. Reminder, our teaching point is that we are going to be adding and subtracting with unlike denominators. So here we go, kiddos. We know this first equation is asking us to do what? Add or subtract. And how do you know? Well, when I look at how much do the cats eat in all, that's my key word, in all, that we are adding these up, okay? So there are a couple different strategies I've taught us of how we can go about finding a common denominator. We have 3, not 2, 3 denominators that we need to consider. And we also have to think, well, now I also have to really think deeply about what number does 4, 5, and 8 have in common. Now, I have my handy dandy multiplication chart, and if I'm trying to identify, here we go. If I'm trying to identify or locate a factor that has 5, 8, and 4 in common, then I'm going to want to look at my 4 column, my 5 column, and my 8 column to see if I can find the numbers in common, right? This is a strategy I've taught us that I really think is a great strategy for us to learn. Well, immediately I see these 2 numbers and I think of what they have in common, right? Because I can also do my multiplying strategy. But that might be a problem. So you really need to think, well, what times 4 What times 5 and what times 8 is going to give me a number where all of these have in common? Okay, so let's take a look. We have 4, 8, and 5. So those numbers not in common. Let's keep it moving. These numbers not in common. Ooh, I see a 16 and a 16. That's pretty cool, but does 5 have 16 in common? Nope. So 16 is out of it. Now bear with me. There is a sound of an alarm going off, but I think that we are okay. So I apologize for that interruption. So let's keep looking. Well, we know 16 isn't going to work, but they did have these in common. Let's keep going. Ooh, I see a 20. That's in common, but what, does 8 fall under that? No, right? We know that 8 times 2 is 16, 8 times 3 is 24. 8 is not a factor of 20, so 20 is out. We're not going to use 20. Now, I'm also going to keep looking and see if we have, oh, we've got 24 in common, but is 24 a factor of 5? No, it is not. So let's keep moving. Now, some of you have likely already figured out the common denominator. If you have, go ahead and write it in the live chat. Okay, let's keep it going. So we know 24 4 and 8 are in common, but not with 5. So let's keep going. 32 and 32, but no, not with the 5. Let's keep it moving. We got 40. Oh my gosh, I see a 40. Look at 40, 40, 40. 40 is gonna be our common denominator. So this is really exciting. I know that 8 is a multiple of 40, 5 is a multiple of 40, and 4 is a multiple of 40. So if that's the case, we're going to just do a little bit of multiplication so that we can make sure these numbers, and specifically these denominators, are in common. So I know what times 8 is going to get me to 40, right? I kind of like love these questions, right? What times 8 equals 40? If you said, well, I'll give some think time. I love this because I see some of us are responding. Go ahead and, if you're doing this live with me, make sure you've gotten this written out. And for those who are in our math small group, thank you so much for being patient. This is the only equation we are going to work on in this lesson. And then I will be posting an exit ticket for you to do a few more equations with Tommy, Sammy, and Goldie. So what times 8 gives me 40? What times 5 is going to give me 40? What times 4 is going to give me a denominator of 40? Check out how I set that up. Now, once you figure out what times this denominator gives you 40, remember that you need to match the numerator and the denominator, because even though we are making a smaller piece because we know that that's what's in common, we are only still multiplying this by 1, so nothing is changing about this fraction. It is still going to be equivalent to 3/8 when we're done. Just like with Sammy, even though we're converting it to a common denominator, because we're multiplying it by an equivalent of 1, in essence, nothing's going to change. This fraction at the end is going to be equivalent to 2/5. Similarly with Goldie, we are only multiplying it by 1 so that this number is going to be equivalent to 1/4. So here is where I am actually going to stop. And your job is to finish this up, but not just that, when you're done with these, you are adding all these up. you're adding these three numbers up. So with that, my lovely mathematicians, if you are in a math small group B today, I will see you. If you need added support, come to the small group. We are going to be completing this together in the small group, and I will be posting the extended exit ticket activity on Google Classroom very